Sensors. So the basic types of temperature sensors are going to be thermocouple, and that works on basically a change in millivoltage that you're going to be monitoring that's going to change proportional to the temperature. RTD, which stands for resistance temperature detector, and that's basically a metal resistor, and as the resistance changes, the amount of your voltage drop across the resistor is going to change in proportion to the temperature. So basically you use Ohm's law to measure the temperature that way. There's a thermistor, which stands for thermal resistor, not to be confused with RTD. The main difference between the two is an RTD is going to be made out of like a metal, and a thermistor is made out of like a ceramic or a polymer type, and that gives it greater precision, which we'll get into a little bit later. Next, there's semiconductor types, and this shouldn't be confused with the miniaturization of these other ones because everything's constantly getting smaller. The semiconductor types are actually made of circuit board materials, transistor type materials, and they're made primarily for the electronics industry so that you can monitor boards and things like that. But once again, they're a different principle, which we'll get into, and many times they can be the same size as miniature versions of these other types, but they do work on a slightly different principle. And lastly, we'll cover infrared, which is using light to measure the temperature. So real quick, I want to get into the worldwide sensor market. The total size is $5 billion. And this graph here is going to cover the European Union, US, and Asia. And the main things to take from this graph is thermocouples right now are the most popular, followed by RTD and IR. IR is the fastest growing. RTD is also growing quickly. And it looks like that by 2022, IR and RTD are looking to bypass thermocouples in popularity. So before I really get into it, I thought I'd give a little brief history as to how we got to where we are now. And if you go back to the beginning here, the actual phenomena of temperature changes and noticing that gases and metals extract or contract at different temperatures was discovered and noted by the ancient Greeks. And then we had the Dark Ages. And in the 1500s, a device called a thermoscope started to appear. Galileo Galilei put a lot of work into these things. And basically all they are is you have water and a gas. There's a tube to open air involved. And basically when the temperature changes, your water or your air contracts or expands, and that changes the level of the air, or these were made in various types. But the idea is you're watching a water level change in reference to temperature. The main problem with these is that there's no scale and they are sensitive to barometric pressure. So they were really used in laboratory environments, and being able to compare one experiment to another, you really couldn't extrapolate anything more than that other than just reference, okay, this is hotter than this or this is cooler than that. Someone came along and they figured out that if you closed that tube and you filled it with water or alcohol, you could make it independent of the barometric pressure, and this is where we get the term thermometer. And around this time, people started to experiment with different scales, but once again, outside the laboratory, it was very hard to share information between different labs because everyone had their own different reference points. So then fast forward here to 1714, and we have the beginning of precision thermometry. And what happened was a scientist came along and he realized that if he took this closed tube and he filled it with mercury instead of water or alcohol, he could get a much more precise measurement. That man's name was Fahrenheit. And he made a scale to go along with it, and it became widely adopted. And that was where being able to measure temperature and share results of your experiments became much easier in a peer-to-peer environment. As a side note, in 1759, a clockmaker discovered that if you take a bimetallic strip, and by bimetallic, just two different metals with different coefficients of expansion, you could also detect the temperature change. Now, he wasn't trying to measure thermometry. He was just trying to balance his clock he was making. It was a chronometer for shipbuilding and ship sailing. And the main problem they had was with temperature changes, the certain gears and things like that, they may change shape, and that would affect your timekeeping. So he came up with this device, which I just so happen to have one right here, that basically reacts to temperature. And so I have a little bimetallic coil here with a needle, and you'll see as I heat up the coil, I get a fairly consistent unraveling of the coil. And this is very repeatable, and this is basically how your dial thermometers work. I was sure many of you have seen the liquid-filled thermometers, so I figured it wasn't necessary to bring one back. But basically, by 1759, the science community has, or at least thinks they have, a pretty good grasp on thermometry. So there's two types of thermometers. There's a non-registering thermometer, much like this one here. And by non-registering, what that means is wherever the thermometer is what temperature it reads. Once you move that thermometer away from the thing that it's measuring, your thermometer is going to start to change values. So it's very hard for you to take a non-registering thermometer, mark the value without writing it down, and then move it to another place for further analysis or to extrapolate anything. For this, you would use a registering thermometer, which in this day and age, it's easy to think of because you just hit the save button on your computer or whatever. But back in these times, you'd use a mechanical slider or maybe a marker on a thermometer just to mark the temperature that you're reading.